You are moving right now at 1,670 kilometers per hour. That's faster than a bullet train, faster than a race car, faster than a commercial jet taking off. And you feel absolutely nothing. No wind in your face, no dizziness, no sense of motion at all. You're just sitting there completely still, while the ground beneath you hurtles through space at speeds that would rip your hair out if you stuck your head out of a car window. Why? What is going on? This is not a trick question. This is real. Right now, as you're reading this, the Earth is spinning. One complete rotation every 24 hours. If you're sitting at the equator, you're moving at 1,670 kilometers per hour. If you're in New York, it's about 1,300 kilometers per hour. Even at the poles, you're spinning just in a tighter circle. The entire planet is a giant carousel and you're on it, but you can't feel a thing. Here's what makes this deeply strange. You know what 1,670 kilometers per hour feels like in other contexts. Imagine you're in a car. You're driving down the highway at 100 kilometers per hour. Now stick your hand out the window. The wind slams into your palm. It pushes your arm back. At just 100 kilometers per hour, the air resistance is powerful. Now imagine going 16 times faster. The wind would be a wall. It would peel the skin off your bones. But right now, you're moving 16 times faster than highway speed, and the air around you is perfectly calm. Your coffee sits peacefully in your cup. Your hair doesn't move. Nothing indicates you're moving at all. So what's the secret? Why doesn't the Earth spin feel like the world's most terrifying roller coaster? The answer is going to sound simple, but understanding why it's true will change how you think about motion forever. You don't feel the Earth spinning because everything around you is spinning with you. The air, the buildings, the trees, your coffee, your body, all of it is moving together at exactly the same speed. And when everything moves together, motion becomes invisible. Let me prove this to you with something you do every single day. You're sitting in a car. The car is driving down a straight road at a perfectly constant 80 kilometers per hour. You're in the passenger seat. You have a cup of water in your hand. What happens to the water? Nothing. It sits there perfectly still in the cup like you're not moving at all. You can lift the cup to your mouth and drink without spilling a drop. You can toss a coin in the air and catch it. You can read a book. You can eat a sandwich. Everything feels completely normal. You don't feel like you're moving 80 kilometers per hour. You feel like you're sitting still. Now the driver slams on the brakes. Suddenly, everything changes. The water lurches forward. Your body strains against the seatbelt. The coin you were tossing flies toward the windshield. You feel motion, violently. But here's the key question. What changed? A second ago, you were moving at 80 kilometers per hour and felt nothing. Now you're moving at 60, then 40, then 20 kilometers per hour and you feel everything. You're actually going slower, but it feels more intense. Why? Because you don't feel speed. You never have. You feel changes in speed. You feel acceleration. When the car was moving at a constant 80 kilometers per hour, you and everything in the car were all moving together. There was no relative motion between you and the car. You were at rest relative to your environment. But when the brakes hit, the car started slowing down. The car's speed changed. But your body wanted to keep moving at 80 kilometers per hour. The seatbelt had to pull you back. The water wanted to keep going forward. That's what you felt, not the speed, the chain. This is the foundation of everything. Motion at constant speed is invisible. You can only detect motion when speed changes, when direction changes, when something accelerates. And the Earth's spin, for all its incredible speed, is almost perfectly constant. The planet has been rotating at roughly the same rate for billions of years. No sudden braking, no swerving, just smooth, steady, endless rotation. So we feel nothing. But wait, the car example doesn't quite explain everything, because in a car, you're in an enclosed space. You're separated from the outside world. When you look out the window, you see trees and buildings rushing past. You know you're moving because the world outside the car is standing still. But on Earth, there is no outside. There's no stationary reference point to compare yourself to. Everything you can see and touch is spinning with you. The ground, the air, the clouds. Even the atmosphere extends hundreds of kilometers up, and it's all rotating with the planet. Think about the air for a moment. This is crucial. When you're in that car driving at 80 kilometers per hour, if you stick your head out the window, the air blasts you. That's because the air outside the car is not moving with the car. The air is still and you're plowing through it at high speed. But on Earth, the air is not still. The atmosphere is stuck to the planet by gravity. It rotates with the Earth. So when you're standing on the ground moving at 1,670 kilometers per hour, the air next to you is also moving at 1,670 kilometers per hour. There's no relative motion between you and the air. No wind, no resistance. You and the air are traveling together like passengers on the same train. Let's test this idea with another everyday experience. You're on a train, a smooth, modern train on a straight track. The train is moving at 200 kilometers per hour. You stand up. You walk down the aisle to the bathroom. Do you get thrown against the back wall? No, you walk normally. You can balance. You can carry a cup of tea. Inside the train, everything feels stationary. That's because you and the train and the air inside the train are all moving together. Now imagine the train suddenly hits the brakes. You go flying forward. That change in speed, that's what you feel. The Earth is the train. You're the passenger. And the ride has been perfectly smooth for your entire life. But here's where it gets interesting. The Earth's spin is not the only motion you're experiencing right now. You're also orbiting the Sun at 107,000 kilometers per hour. The Sun is orbiting the center of our galaxy at 720,000 kilometers per hour. The galaxy itself is moving through space at over 2 million kilometers per hour. You are on a cosmic bullet train stacked on top of other bullet trains, all moving at insane speeds. And you feel none of it, because all of these motions are constant, smooth. No sudden turns, no braking, just gliding through the void. So the real question becomes this. If constant motion is invisible, what would it take for you to actually feel the Earth spin? You'd need the Earth to change its speed. Speed up or slow down. If the Earth suddenly stopped spinning, you would definitely feel that. In fact, you wouldn't survive it. If the Earth's rotation stopped instantly, you would keep moving at 1,670 kilometers per hour. You'd be flung forward like a passenger in a car that just hit a wall. Everything not bolted down would go flying. The oceans would slosh across continents. The atmosphere would keep moving, creating winds beyond comprehension. It would be apocalyptic. But as long as the Earth keeps spinning at its steady rate, we feel nothing. Now let's address something you might be wondering. What about spinning in circles? If you spin around in your room, you get dizzy. You feel the rotation, but the Earth is spinning. Why don't we get dizzy? Great question. When you spin in place, you're rotating fast over a very small circle. Your body completes a full rotation in maybe 2 seconds. That's a lot of direction change happening very quickly. Your inner ear, which controls balance, detects that rapid change and sends signals to your brain. Dizzy. But Earth's rotation is massive and slow. If you're standing at the equator, you're moving in a circle with a radius of 6,378 kilometers. To complete one rotation takes 24 hours. That's 1,440 minutes, 86,400 seconds. Your direction is changing so slowly that your inner ear can't detect it. It's like the difference between spinning on a merry-go-round that completes a rotation every 2 seconds versus one that takes an entire day. The day-long rotation is so gradual, so gentle, that your balance system registers it as standing still. Here's another way to think about it. Imagine you're on a gigantic turntable, so gigantic that you can't see the edge. The turntable rotates once every 24 hours. You're standing near the center. Are you spinning? Technically, yes. But the rotation is so slow and so smooth that you'd never know unless someone told you. That's Earth. A colossal, imperceptibly slow turntable carrying you through space. But there's one more piece to this puzzle. One more reason you don't feel the spin. Gravity. Gravity is pulling you down toward the center of the Earth with a force strong enough to keep you planted on the surface despite the spin. When something spins, there's a centrifugal effect. Objects want to fly outward. If you spin a bucket of water over your head fast enough, the water doesn't fall out. It's pushed outward against the bottom of the bucket. The Earth's spin does create a tiny centrifugal force that tries to fling you off into space, but gravity is far, far stronger. Gravity wins. It holds you down. At the equator, where the spin is fastest, gravity is about 0.3% weaker than at the poles because of this centrifugal effect. But 0.3% is nothing. You can't feel it. Gravity keeps you firmly attached to the spinning planet. Let's go back to the car one more time. You're driving, constant speed, smooth road, you feel stationary. Now the car goes around a curve. Even if the speedometer stays at 80 kilometers per hour, you feel pushed to the side. Why? Because you're changing direction. Your body wants to go straight, but the car is turning. That's acceleration. Turning is acceleration even at constant speed. So why don't we feel the Earth turning as it spins? Because the turn is so gradual. At the equator, it takes 24 hours to complete one 360-degree turn. That's 15 degrees per hour, 0.25 degrees per minute. Your body cannot detect such a slow change in direction. It's invisible. Think about standing on a corner waiting to cross the street. The Earth just rotated you 0.004 degrees. Did you feel it? No, because it's imperceptible, but it happened. You moved. The planet carried you. And it will carry you another 0.004 degrees in the next minute, and the next, forever. A slow, steady spin that never stops and never changes pace. There's a beautiful experiment you can do that proves the Earth is spinning, even though you can't feel it. It's called a Foucault pendulum. You hang a very long, heavy pendulum from a high ceiling. You set it swinging in a straight line. Over time, the pendulum appears to rotate. Its swing slowly changes direction. But the pendulum isn't rotating. The Earth beneath it is. The pendulum is swinging in a fixed direction in space, and the ground is turning underneath it. It's one of the most elegant demonstrations of Earth's rotation. You can see it happening, even though you can't feel it. So here's the complete answer. You don't feel the Earth spinning because motion at constant speed is undetectable. You only feel changes in motion. The Earth spins at a steady 1,670 kilometers per hour at the equator and has done so for billions of years. Everything around you, the air, the water, the ground, your body, all of it moves together. There's no relative motion, no wind, no resistance. Your inner ear can't detect the slow, gradual rotation. Gravity holds you down, overpowering the tiny centrifugal effect, and there's no stationary reference point to compare yourself to. You are inside the motion. You are part of it. And constant motion, no matter how fast, feels exactly like standing still. This is one of the most important principles in physics. It's called Galilean relativity. Galileo figured this out 400 years ago. He said that if you're in the cabin of a smoothly sailing ship, there's no experiment you can do inside the cabin that will tell you if the ship is moving or docked. Drop something, it falls straight down. Toss a ball, it arcs normally. Everything behaves as if you're stationary. Because, relative to the cabin, you are. Motion is relative. There is no absolute rest. There is no absolute motion. There is only motion compared to something else. Einstein took this idea and expanded it into special relativity. He realized that even light behaves this way. The laws of physics are the same whether you're standing still or moving at constant speed. There's no privileged reference frame, no special place in the universe that counts as truly stationary. We're all moving, always. The question is, moving relative to what? You might be thinking, okay, but I can tell when I'm moving. When I'm in a car, I know I'm moving. I see the world passing by. Yes, but that's because you're comparing yourself to the ground. You see relative motion between you and the Earth. But if you close your eyes, if you eliminate that outside reference and the car is moving smoothly at constant speed on a straight road, you cannot tell you're moving. Your body has no internal sense of speed, only change. This is why airplane passengers can walk around, eat meals, and sleep comfortably while flying at 900 kilometers per hour. The plane is moving smoothly, no sudden accelerations. Everything inside the plane moves together. It feels like rest until the turbulence hits. Then you feel every bump, every drop, every change, not because of speed, because of acceleration. So the next time you're sitting in your chair, remember this. You're on a planet spinning at over 1,600 kilometers per hour. You're orbiting the sun at over 100,000 kilometers per hour. You're sailing through the galaxy at nearly 1,000,000 kilometers per hour. You are in constant, relentless motion. And yet, you feel nothing, because everything around you is coming along for the ride. You are at rest in your own frame of reference, and that's the only frame that matters to your senses. Motion is invisible when it's constant. You only feel the change, the break, the turn, the bump. The rest is silence. The earth spins beneath you smooth and steady and will continue spinning long after you're gone. And you'll never feel a thing. That's not a flaw, that's physics. That's how motion works. And now you know why standing still and moving at 1,670 kilometers per hour are, in your direct experience, exactly the same thing. The universe is moving. You are moving. And feeling still is the most natural thing in the world.